Hello, good day. Well, for today I want to show you how can you make addition and subtractions of radicals, because it's common to have some doubts or to have some questions also about this topic. So the first situation that you need to understand is, for example, and I'm gonna put a very basic example, is imagine that you have apples, okay? You have apples. And if you want to make the addition about the apples, so for example, let's gonna take the first letter. So let's gonna say then I have 1 apple plus 2 apples plus 3 apples. And finally I'm gonna have, if I make the addition, 1 plus 2 plus 3 is gonna be 6 apples, okay? Well, if I want to make the addition about how many apples do I have, the only thing that I need to do is to check that everything is an apple. Okay, it sounds simple, but it's the idea. Because, for example, let's gonna say that I want to check, or I want to make the addition with a peach. Okay, so for example, let's gonna say that I have 1 peach plus 2 peach plus 3 peaches, and additionally, I want to make like a plus 6 apples. So, for example, here, if I want to make the addition about how many peaches do I have, it's only 1 plus 2 plus 3, but there's gonna be 3 peaches, okay? Oh, sorry, 6, not 3, 6. 6. And, for example, here I have 6 apples plus 6 apples. So notice here one situation. I can't combine, okay? I can't combine the peaches, I can't combine the apples, okay? One thing is obvious, but one thing is a peach, another thing is an apple. So it's gonna be something similar here when we talk about the algebra, when we talk about the radicals, okay? We need to have the same expression. So let's gonna solve the first exercise. Okay, so here, for example, I have the first situation that we need to do, or that I need to check is, let's gonna check that we have the same expression. For example, here I have a square root of 3x. Here I have a square root of x squared, and here I have plus 2 a square root of 3x. So for example, here, check, we have the same expression here and here. 3x a square root of 3x, sorry. So about this, for example, I can make the addition, okay? I can make a square root of 3x plus 2 a square root of 3x, okay? Imagine this, and it's like I say about the apples, okay? Imagine here we have apple and apple, okay? We have 1 apple and 2 apples. So finally, if I make the addition here, only about these two, okay? It's gonna be 3 square root of 3x, okay? Because 1 plus 2 is gonna be 3, okay? And here, in the middle, we have a square root of x squared. So here we have the same square, that is a square root, and here I have the same exponent, that is a square. So we can cancel this, okay? For example, here it's gonna be only x. So finally, I'm gonna put together this, and I'm gonna write the result, or rewrite the simplification about this operation. So it's gonna be 3 square root of 3x plus x, and that's gonna be the result for this one. Okay, let's gonna solve the next one. Okay, here we have another exercise. So let's gonna check this situation. For example, here we have in both cases we have the square root, so that's a good situation. But here inside of the parentheses, check, we have 2x plus 5 and we have 3x minus 1. Remember, according to the first example, that for us it was possible to make the addition about a square root of 3x plus 2 times a square root of 3x, okay? And we got 3 square root of 3x. Because here inside the circle we have the same expression, a square root of 3x. Here check the difference. is not the same expression. So if we have this situation, the answer is not possible to simplify. Okay, so for this situation, well, we can't do anything. Okay, we can't make the addition or the subtraction or whatever is the operation that is here. Okay, because it's not possible. I hope then this is clear. Well, let's gonna solve the next one. Okay, so here, for example, check this operation. Here, let's gonna analyze the next case. Because at the beginning, if you analyze the situations that we have inside of the square root, we continue with the same case. It's not the same, okay? We have a cube, a to the fifth, a to the square, okay? So at the beginning, we can think like, oh, okay, it's not possible to simplify, but it is, okay? How can we do this? It's simple. We need to apply the square root. And for this, we need to apply also, well, something related about the simplification. So here, imagine this. Let's gonna split this a to the cube into factors. Okay, it's gonna say is, gonna change this. Is for example, a square times a. Okay, here something similar. We can split this like a to the cube times a square. Okay, and here, well, we can cancel this because we have a square and the square root, so we have only a. Okay. Here, well, if someone is asking like how is possible to split this, well, I just need to explain this, and if someone else knows this, well, you can advance the video. But for example, here we have a to the cube, so we need to use the properties of the exponents. What is the properties of the exponents here? Apply it is when you have the same base, that is the case here, like the a, and you have a multiplication, for example, like this, a squared times a. Here, well, I didn't write the exponent here, but it's a 1, okay? Always when you see it and there is a letter and you don't see any number, we consider like it's a 1. So here, for example, we have the a squared and a to the 1, and we have the same base, I repeat, is the a. So the only thing that we need to do is make the addition. Is, for example, 2 plus 1. Make the addition about the exponents. And finally, we obtain a cube. Okay? So here, for this reason, we can split this. The idea to separate this is because now, check another property. This is more about not the exponent, it's more about the radicals. The radical says when you have, for example, in this case, it's going to be a squared times a. We can separate like this into square roots. It's going to be like a squared times a, well, a square root of a, okay? It's going to be the same situation. So because of this, we can, well, let's going to rewrite all these expressions that we have here. This not, okay, because we already canceled the square root, but the first two. So we have a squared times a square root of a, a little, and okay, write this in a better way, plus, because remember this is an addition here, and we split again. We have, it's gonna open a parenthesis, so it's gonna be square root a to the cube times square root a squared. And here minus over here, so we can put here, so it's a, okay? So now we have this expression, okay? And we continue with the simplification. So now if you check this, we can apply here or we can cancel this. For example, we have the a squared with the a, that's going to be a, times the square root of a, plus, here, well, we can put this like a to the cube, square root, but here we can cancel a squared and a, so we can express like this, square root of a to the cube minus a, okay? And here we can continue with simplifications. Not here. Here is not possible to simplify anymore. Not here. But what about this? Over here. So, for example, here we have a square root of a to the cube. We apply the same property, okay? We can split this and we can say a squared times the square root of a, okay? So, we rewrite like a square root of a plus a times this square root of a squared times square root of a minus a. So if we continue, we need to apply this. It's going to be, we rewrite a times the square root of a plus a square root of a squared. So it's going to be a times square root of a minus a. So here, what is the situation? Here we can say, for example, a square root of a plus a squared of a minus a, okay? And here we have something special, because that's the marker. This and this. It's not possible to make the addition, okay? It's not possible to apply this. Why? Because here the a is not like the same a squared, okay? It's different. So for this reason, because we have a different expression, it's not possible. It's not matter if we have here a square root of a. A squared is not the same like a. So for this situation, that's gonna mark this one. It's the answer, okay? That's the final answer. So well, I hope that you understand everything. If you have a question, you can put, and also you can put in the comments, and also you can, suggest another kind of topic or subject related about this, about algebra or math, and we can solve it here in a video. So have a good day and see you on the next time. Bye.